Okay. So my main goal for this last day of new material is to show you how to do a hypothesis test when we are comparing two populations. First of all, a reminder of the conditions. We would need a simple random sample from both populations, and that those samples would have been selected independently of each other. We won't know mu or sigma for either population. So the only other thing we'll know, if we have both populations are normally distributed on the variable of interest, great. Otherwise, they need to be of similar shape with no strong outliers. Go when class is over, pick up your exam, and there's a practice final here. Okay. So, try to get some luck here to read this. In 19.38, we're told durable press cotton fabrics are treated to improve their recovery from wrinkles after washing. Unfortunately, the treatment also reduces the strength of the fabric. So a study compared the breaking strength of fabrics treated by two commercial durable press processes. 5 swatches of the same fabric were assigned at random to each process. Here are the data. So we have these two things to help get rid of the wrinkles. One's called Permafresh, and the other's called Highlight. And we only have a sample of 5 of each. But let's assume that those samples are simple random samples, change independently of each other. So we're going to be checking condition 2 here in a moment. Can somebody read that off if you've got the page open there, what the 5 scores were for each? Does anybody have that page? No. Anybody? Anybody? Bueller? Bueller?
29.9.
And it's for Permafresh?
Yes.
Okay.
30.7.
Okay.
30.
Exactly 30?
Yep.
Okay.
29.5.
Okay.
27.6. 28.8.
Oh, there's one more?
No, I'm talking about the next one.
Okay, 28.
0.8.
All right.
23.9.
3.9.
27.
Okay.
22.1. 24.2.
4.2. All right. In part A, we are asked, do the sample means suggest that one of the processes is superior in breaking strength? In other words, do we have one X bar bigger than the other? And then the question would be, is it significantly bigger? So, before we name group 1 and group 2, which one's group 1, which one's group 2, let's find out what those sample means are. And remember, although it'd be easy to add up these 5, and divide by 5, and then do it for the other groups, we're going to need other information. So, okay, the first one was 29.9, you said? 30.7, 30, 29.5, and 27.6. Do I have that entered incorrectly?
Yeah.
Okay. Then 28.8 for the next group. 23.9. 27. 22.1. And 24.2. Do you remember how to get X bar for one of those columns?
That,
Mm-hmm.
count,
Mm-hmm.
one,
Right, first one. Okay, so let's say for permafresh, I put that in list 1. So let's just scroll down and calculate, and bam, X bar is exactly 29.54. What else are we going to need from that list?
isn't it X?
The sample standard deviation. Okay. Now I didn't look when I was grading the last page as to did somebody copy down sigma. Remember, we don't have sigma in the T procedures. This is a sample, not a population. So in the T procedures, we'll be copying S, not sigma. All right. So S for this group. I'm not going to round it. Copy everything it gives. 7, 4, 7, 5, 9, 9. And then to get that for the other group, we're just going to go back to the same submenu, calc, and one variable statistics, to do it for list 2 for the highlight. So, variable statistics for list 2. How do we change that from L1 to L2? You remember? Second and 2. Alright. So X bar for that group is 25.2. And S for that group, 2.6692, 69563. What was it asking again? Alex, I know you've got the page there. What's part A asking about?
The sample means suggests that one of the process is superior in breaking strength.
Okay, and these values were breaking strength, so which one seems to have the better breaking strength?
whatever.
The first one, because it's higher. It takes more to mess up the material. So why don't we call that group 1? Put sub 1s on the X bar and the S. And similarly for highlight, I'll put 2s there. So for part A, we've got 29.54 greater than 25.2. So it looks like Permafresh has a higher, better breaking strength. All right. Is that all it asked for in part A? I think it is. Is that right? Okay. For those of you that are coming a little later, make sure you take your test back at the end of class and that you get a copy of the sample file. Same rule applies for this last homework, by the way. If you need to scan it and email it to me later in the day, that's still okay. And I'll start the scoring tomorrow. But if you have it ready files on the right-hand part of the desk. Part B, make a stem plot for both samples. The authors claim that there is an outlier in the permafresh sample. Before I read the rest, what we don't want is a separate stem plot for the two different samples. We want to see this together at once for quick, easy comparison. So actually what they mean, and you'll see this when you do the reading of the chapter, they mean to make a new kind of stem plot. It's just a slight twist on what we've done previously. It's called a back-to-back stem plot. Remember that leaves only have one digit. So since these were, some of them were going into the tens place, the tens place is going to be your digit. When I put 22 point and then a 1 there, that's the score right here. Then I have a 23.9, a 27, i.e. 27.0. What am I missing here? The 24.2, that third one there, is right here. And finally, 28.8 is the last one I wrote on that side. That one I'm making it look, besides knowing what to do with the fact that there's a decimal, the fact is still, for each score, there should only be one digit per lead. So we were taking this stuff in the tens place. And remember what we said early in the semester. 5 or 6 groups at a minimum, and 12 at a maximum. That was for the histograms, but this is related. Doing it this way, I'm going to wind up with 9, which is in that range from 5 to 12. Can you tell what I'm doing here for the permafresh? I'm still using the tens place as the digit to put in the stem. Something else is going on here. Can you tell what it is? What's the very first one I wrote on the left-hand side?
27.6.
27.6. Okay. Go down to the next row with entries in it, and you should see something a little unusual.
We're working out.
We work out from the stems in either direction. So in this one, I was going by traditional left to right, least to greatest order. Well, there was nothing that was in the same stem on this one. But if there had been, we would have gone left to right, least to greatest. As you pointed out, Jalen, our 29.5 and our 29.9 on the other side of this back-to-back stem plot, it's in that reverse order. Instead of left to right, least to greatest, we're working outward from the stem. So it's reversed that least to greatest order. But then you're going to do the same thing for the 30.0 and the 30.7. Doing it that way, you're looking at the two together. So if you make 2 separate regular stem plots, you can still do some comparison, but it's going to be harder to look at least a little bit. If we're trying to compare 2 populations, having it back to back makes it go a little more quickly that way. Questions? Does it make sense? Okay. Now, let's see what the rest of part B said. They were claiming there was an outlier, so which one looks like it might be an outlier for permafresh?
27.6.
27.6. Okay. Alright, so let's see what the rest of what this is. With just 5 observations per group, we worry that this outlier will affect our conclusions, which we're going to deal with in part C. We're going to do a hypothesis test that permafresh is superior, both with the outlier and without. And we got to be careful when we take out the outlier. By the way, they said mild outlier. Only the picture will suggest this. Does anybody remember back from chapter 2, stuff on our first test, this was very early, how you can check numerically for whether you have an outlier? Okay, which we will have that information on here. We want to go back to list 1. Quartile 1 is 28.55. Quartile 3 is 30.35. Any memory of what we do with those? Subtract them, that gets our interquartile range. And what is that? 1.8. Is that right?
Yeah.
Okay. And something else we did with that. Remember interquartile range, in between those two are the middle 50% of the scores, or really close to 50% of the scores. And we did something conservative. What do we do to that interquartile range before we then try to see if we have outliers?
Multiply it times
1.5. And I believe, in part because I've done this question before, but also half of 1.8 is 0.9. 1.8 plus 0.9, 2.7. Okay. What do we do with that 2.7?
Subtract from quartile.
Okay, and something else as well. So, I didn't look closely enough what was X bar. We've got a mean more than the median here. So, it's probably going to be skewed right. We're going to have something like this. But in any case, by multiplying by 1.5, we're going even further apart than the middle 50% are. And then we're saying, okay, if we go 2.7 units away from Q1, go to the left. 28.55 minus 2.7, looks like that's going to be 25.85. Is that right? Okay. We want to see if our lowest score, or any scores, not just the lowest score, but are there any scores that are even further away from quartile 1 on its left than that? So I didn't write them in order, but are any of these scores below 25.85?
No.
No. Okay, definitely not. By the way, the other direction, we would have added to quartile 3. So that we get 33.05. And there's nothing that high either. So according to the arithmetic approach, it doesn't seem like there are any outliers. which is why I think the authors use the adjective, if adjective is the right word. Yeah. Mild outlier that suggests itself in the picture rather than the arithmetic. Okay? So, when we're testing two populations, we want to see, is there a difference in the breaking strength? What is the null hypothesis? Should be kind of like that last question on the test, although there's, by doing matched pairs, it's like we have one sample in that case. That one was the TOEFL question, right? Test of English as a foreign language. Is that the one you had on the test? Okay. So in that case, we're talking about a single mean of the mean of the differences in scores. Did it go up from the first test to the second attempt? What was the null hypothesis though? What number was in there? So it's going to be equals in your null hypothesis. What number did we have it equal to? We talked about it on Monday. Zero. Assume that there is no difference. So, in part C, first we're doing this with the outlier. We have H naught is that the two means are equal, the two population means. In other words, the difference between the two is zero. Now, as for whether we just want to see, is there a difference or not, or is there a specific direction? Is it a two-sided or one-sided test? Let's see what the authors say there in part C. Test the hypotheses against the two-sided alternative twice. Once with the outlier and once without. Now, really, like what I'd like to test, since x1 bar is bigger than x2 bar, I'd want to see if mu1 is greater than mu2. Mu1 minus mu2 greater than 0. But they want us to do a two-sided test, so let's do that. Just not equals there. For the first part, with the outlier, I'm going to do it the long way, and I'll show you how to use TCDF again. Then, since we will almost be repeating ourselves, except when you take out the outlier, that's going to change x1 bar and s1. Does that make sense? If you take out the 27.6, that these should change. Does that make sense?
But I thought 27.6 isn't an outlier. Should we just treat it?
Well, with the arithmetic, yes, but from the picture, it looks like it's a mild outlier. Here's the overall point. That's a good question. Here's the overall point. Even a mild outlier could affect whether we would say reject H naught versus fail to reject H naught. Whether we're going to have a difference here is what we're going to find out by testing both ways. Even if we fail to reject in H naught in both, there are examples where keeping the outlier leads you to reject H naught, and if you take it out, oh, that really affected the calculations. We should be a little more conservative. That outlier could just be this rare instance. Remember, we've only got 5 of each. That outlier could really throw it off. And if you're saying reject, what if this is some dry cleaning company that's trying to decide which one they're going to invest in? If they think that Permafresh is so great and invest thousands of dollars, only to learn later, oh, Permafresh isn't all that great. It's really about the same as Highlight. And maybe Permafresh is the more expensive one. See my point?
Yeah.
Okay? So, when taking out the outlier, we may get a switch from reject H naught to fail to reject H naught. At least in some situations. Okay, so the long way. We don't need it right now, but let's answer it anyway. How many degrees of freedom are there?
4.
4. We're lucky that take away 1 from either sample size, you're comparing 4 versus 4. It's a tie. When we take out the outlier, whoever said 3 is going to be right. So right now, though, yes, it is 4. Calculate T. Trying to get across on Monday and through this homework assignment, there's not a huge change. One thing that is new for both confidence intervals and hypothesis testing is we're going to have x1 bar minus x2 bar instead of just a single x bar. But then you're subtracting the claimed difference in means is 0. Taken away from this, that's still going to be this. What did we used to put in the denominator? We had a fraction going in there before. Okay? Or, in the last chapter, S over square root of n. That was your standard error. Now that we have two populations to compare, that part that you saw in the homework, that's our formula for the standard error when we're dealing with two samples and two populations. Okay? And you can put this in all at once. You can put parentheses around the subtraction in the numerator, and you can put, well, in fact, your calculator probably automatically puts parentheses around what's inside here. But if you want to break it down, or for some reason the calculator makes you do it a step at a time, can't imagine why. We've all got a TI 83 or 84, right? Okay. Let me see if I have this typed up here. Check me on the subtraction for the numerator. 4.34, doing x1 bar minus x2 bar. Is that what you're getting? Anybody back that up? Yes? Okay. Taking our S1 and S2, let's see if I typed the right stuff a couple years ago. I've used this as a homework problem before, so this is a part of the key from about 2 years ago. It looks like it agrees. If you have to break it down, which thing would you have to do first? Of the squaring, the division, and the addition, what's first? Exponents. So square this, divide by 5. Square that, divide by 5. Then add. Take the square root last. Don't try to get the square root to cancel the squares. That doesn't work when there's addition or subtraction in between those terms. Either way you do it, breaking it down step by step, or if you're typing it in all at once, tell me if you are getting 1.3029, 19798. Look at that. How many have seen Bruce Almighty? How many? Okay, here's my Steve Carell imitation. 1.3029.
And you did the shot like 60 minutes.
That's it. I forgot that one. So let's see if anybody backs up that final bit after taking the square root. Everybody getting the same?
I second motion.
Second. Can I get a third or a fourth? Angie, did you get it already? Yeah. You got the same? Anybody else that's backing it up? Yes? Okay. All right, now this was actually for a related question as it refers to this. We've got the 4.34 then over that standard error. The reason I was saying on the test, rounded 3 places the way it does in table C, is I have run into a couple, not a lot, but a couple of questions where when we look at table C, let's see if I have a printout of table C here. I don't. Tell you what, I'm going to log into Blackboard real quick. I've got the table posted up there. Oh, not that one. Picture Dr. Lopez there. Has anybody talked to Dr. Lopez before? No? You don't talk to him about the ancient aliens? Nah. Alright. Well, they took that picture after he got his haircut. I'm trying to match what his hair length used to be. It's going to take me a couple more years. Anyway. Table C. If you have gone to the course documents recently, sometimes, at least on my laptop at home, because of these videos down here, it takes a little longer to load, so be willing to go for that. Tables, there we go. Table C. So to get back to my point, whether we're talking about T's or even back at Z's, what if somebody got 1.28 well, okay. This even indicates a problem with going out 3 places. Any rounding. What if you had 1.2819? Which pair of numbers is that between?
1.016. I think that's
A 3, actually. But 1.036
and 1.282.
is just below that. Okay. So even when we go to their 3 places that they're giving us, 1.2819 would actually round up to 1.282. So we'd be thinking that we're talking about being in between here, and then look down at lower probabilities. If the probabilities are low enough, what do you do to the null hypothesis? If the probabilities are low enough. Reject H naught. Remember to say the H naught part. If P is less than or equal to alpha. So see, even when we go as far as they're showing, you do some rounding, then you might wind up rejecting where somebody else who rounds their way fails to reject H naught. So at least go as far as what they show. Don't round it to 2 places unless you're going to use table A instead of table C. Anyway, let's do that division, and then when we get, we're going to be looking up in the 4 rows of 4 degrees of freedom row. So, let's see here.
3.300278.
This moment. Alright, so we have 4.34. Correct? Yeah. The difference in sample mean. Divided by 3, divided. Divided by 3 point.
1 point.
Oh, 1 point. Okay, keep going.
302919798.
So about 3.331. Anybody backing that up?
Yeah.
Yes? How many do? Okay, that's quite a few people. All right, so let's look at the table. 4 degrees of freedom. That's between these two, right?
See,
2.999. You want to show this. If you're not using the calculator approach, before you start throwing me values from the bottom, tell me what you were in between. That made it hard for me to know. Sometimes I'm like, okay, I know they really knew, because otherwise we had exactly the same stuff. But this is stuff about T. What was the other one? 3.747? And then when you look down below, that's about P. So we're trying to trap P between two values. Don't forget, the farther right you go, whatever row we're in, down at the bottom, the probabilities get lower. So this switches direction. So tracking down from these two, which row are we looking at here? Two-sided. So it looks like we've got 0.04 and 0.02. Were we given an alpha somewhere in the reading that I didn't spot? No? Okay, the authors are kind of sloppy about that throughout the book, whereas you saw in the test, and this is going to be the same on the plan. I should be stating an alpha. Is there any alpha where we could reject H naught? We had
alpha,
3 typical values. What were you going to say, Jim?
I was going to say alpha could be 5.
Okay. What's another typical value where we could still reject H naught? 5%, 1%. What's another typical value of alpha we could use? 10%. If we're already rejecting for a smaller value of alpha, if alpha is 0.05, 5%, and we have P is less than the bigger of these two, then we'd be rejecting H naught. Where's 10% in relation to all this line here? It's further out, so P would still be less than that, right? At the 5 or 10% level. Whereas 1%, go back to this line here, that's less than a 0.01, putting P bigger than 0.01. Again, it should be something that the people that are concerned about this stuff would be stating in advance. What level, how much proof do they need in the durable press industry? If they need 1%, then we would fail to reject H naught at that level. Questions?
If it doesn't give us an alpha, we just want to see the typical.
You can tell me anything from, pick one of those 3, and then say, this would I reject H naught or fail to reject. But again, you notice on the test, whenever I had hypothesis testing, you had an alpha. Even the homework, which was out of the book, I would say, oh, question 1, the author's didn't give an alpha, use alpha as 1%. You know? So, I try to remember to include that stuff. Otherwise, until you get into the field you're going into, if you're going to be doing hypothesis testing in the future, they should be giving you some sort of indication, say in civil engineering, what alpha do they use? What alpha gets used in psychology or sociology research? Okay? Alright, let's see how this would look with TCDF now. You've got to use the T in this case. What's the last entry supposed to be with TCDF? Everybody remember? Degrees of freedom. So, somebody help me? Thank you. Okay. It's probably going on YouTube for some reason. Anyway, by having already figured out T, we've already standardized to a T distribution with 4 degrees of freedom, a mean of 0, and a standard deviation of 1. So all that's left to do with TCDF is lower and upper bounds.
You forgot to use that.
You are correct. Hopefully I would have caught that by the time we finished, but thank you. A lot of people have messed up this part if they're trying to use, and maybe a quarter to half the people for normal CDF and TCDF. Visualize or draw a picture. We standardize, so where is that value of T in relation to 0 on the horizontal axis? Where is 3.331? To the right. It's higher than that. That should be, since we want to find out if we're in a tail, in this case, since it's already to the right, are we in the right tail? Which would mean we're shading above that. So we want 3.331 first, then what? Okay, let's see what we get there. And yes, Jalen, we need that times 2 part. Thanks again. Let's see here. 2 times TCDF, that's the 6th choice. 3.331, 10 to the 99, and 4 degrees of freedom. That is something that is coming out between 2% and 4%. So either way, depending on what alpha was, our typical ones of 1% or 5% or 10%, we'd still conclude in these 2 cases, P is less than that, either one of these, so reject H naught. And otherwise, if it's 1%, fail to reject H naught. Question so far?
Why do we shade to the right if you put 1?
Okay, remember what we're looking for is extreme scores that have low probabilities. So technically, it's also over here because it's a 2-sided test. If we're saying alpha is 5%, we want a total of 5% from each side. So is that 3.331 so unusual a score? Should we have that difference between sample means if in fact there is no difference? And what the probabilities are telling us is, no, that's a pretty extreme score. It's pretty unlikely that if this were true, that we get a difference in sample means like we did. So it's an extreme, it's out in the tails. That's why we've got T is bigger than 0, and we're going even further to the right of that. Okay? If T had been less than 0, we would have had shading to the left. and your lower bound would be negative 10 to the 99. And then you could have here something like negative 3.331. Questions? Well, let's find out what happens real quick here if we take out the 27.6 from the Permafresh. I'm going to speed things up by telling the calculator to give me the difference in means and the standard deviations as follows. I need a numerator. I'm going to change the mode so you can see the entire line I'm going to type in. In the numerator, I need the mean of L1. So we can do second and above status list. Mass sub option. This is so I don't have to copy down all the new numbers. Mean of list 1 minus mean of list 2 we found out a few classes back that in that same sub-menu, the standard deviation is talking about is in fact the sample standard deviation, the S's. So standard deviation of list 1, that's going to get squared. So that's choice 7. We've got to square that. What else did we do besides squaring our standard deviations? Divided by the sample size. What's the sample size now for Permafresh? 4, because we've taken out the outlier. And then a similar setup here for standard deviation of list 2 squared. That's still going to be divided by 5.
Shouldn't it be list 2?
Yes, I can fix that up real quick. That's still going to be divided by 5. We didn't take any score out of that group from highlight. And then after that division, I've got the addition that's in between the two fractions, so I can close the parentheses to close off the calculation of SE. And of the entire thing, because I already had x1 bar minus x2 bar up there. Now we've got a bigger value of t. We could either take that exact value or round it to 3.956. But how many degrees of freedom did you tell me there would be? 3, because we took out 1 from one group. So you'd have minus 1 from each. And the minimum of 3 and 4 is 3. So now I'll put in 3.956 and change the degrees of freedom to 3. Still have that 2 times, thanks to Jalen's reminder, and say 2-sided test. Now in this particular question, we still get something that's between 0.02 and 0.04. So in this particular question, at the 5 or 10% level, we'd still be rejecting H0. Seems like the population mean breaking strength of Permafresh is higher, better than the mean breaking strength for highlight. And we still fail to reject at the 1% level, but the fact is, you can run in easily enough. I'd say, let's take a guess, 50% of the questions where you think there's an outlier, particularly if it's kind of strong, it would change your conclusion. Just because it didn't here doesn't mean it can't in another example. Questions? Alright, those will have to know later. If you've got the homework, let me get that. If you can scan an email, do that before midnight. Anybody that just get the practice data, pick that up? Brooke, here's your 10 next. With Diane Chavez. Abel? Nope, 4 afterwards. Bill?
Are we giving the section?
As I was saying Monday, there was a time between last week. So you just have to get as much out of the final as you can. And that is practice went a lot here already. It is wrong. That's an example of one that was given by not me, but me with 2 others. It's what they want as well.
And that's however long however long that is how long it takes.
It's gonna give you a good idea. And so if that means,
I'm screwed.
that you've got to move more quickly on.
I'm screwed.
Okay,
Thank you.
it's gonna be very similar to this semester.
Kind of super easy.
Yeah, I don't know why we changed that, but all of the years that far, we've had right? So I'm gonna make it something like that.
Wow.
It doesn't hurt, but there wouldn't be that much if there was. Okay. Mhm. I don't want to hear this, my plus. Again, you need the average. And once you've got an average that's still in the C range without any curve impact. That's something to keep in mind. Okay? So as I told everybody else, you just do as much as you can on a final, and then let me go from there with curving. Okay?
So one question.
Okay?
So this final question. Let me turn off the light here. Let me also turn off the video on this shot I already did.